Now, this video is to let us know how to construct a template from choke information. So if you have read all the notes there, we're going to just go straight to construct the template. I'm going to solve my own problem. Let me see. Okay, I have a problem here. We're going to use that to demonstrate how to use the template. You are going to be constructing a template. Okay. Now, this is what you want to do. The problem I want to solve is okay, let me open up the template. You're going to download the template chokes. Chokes excellent. That's the template. Now, what you need to do for this template is to see your input values. You put your input values. In my own problem, these are my input values. The upstream pressure, downstream pressure of a choke. Remember, the downstream pressure is the pressure at the throat of the choke. Then this is the size of the choke, which is the diameter of the downstream diameter. This one is the upstream diameter, which is the flow line inside diameter. That's the specific gravity of the gas. Then this is the K. That's the specific gas ratio, specific heat capacity ratio. Then this is the upstream temperature. So for this template, we're going to, with all these given values, we are going to be able to calculate the flow rate and the temperature at the exit. That's at the throat. Usually the temperature is cold, and we're going to determine whether we need to heat up the exit to prevent icing. Now I've provided you the equation, all the equations you need for this template. So now these are the given values. This last one, you need to, depending on the type of choke you are given. If you are given a nozzle, you put one there. If you are given orifice, in my own case, it is a nozzle, so I put one there. Okay, now let's start with the first thing here. Is what you have to do is to fill up all the equations there. So the first thing here is the upstream temperature, to convert it to Rankine. So you are given the temperature here. Remember, in Excel, if you want to start equation, you put equals to first. So I do equals. How do I convert to Rankine? I just click on the temperature, which is 70 here, plus 460. So that's the first equation there. I click OK. So that's 530 Rankine. The next one is, what is the diameter ratio? Beta. Diameter ratio is the choke size divided by the inside diameter of the flow line. So which is, so I do equals this choke size slash flow line diameter. So that's our beta, 0.75. Now choke area, that's the, okay, choke area is going to be equals pi d squared over 4. Pi in Excel, you just type pi, pi, then you use open and close bracket. Excel counts it as a function, so it understands, it's going to put the value there. That's pi. Then I do star d squared. I click on d squared, which is the choke size. Now to power in Excel, you do shift 6, the number 6, which is cap. It's a cap. Then to power what? 2. Then slash 4, That's pi d squared over 4/4. So that's the choke area in inch squared. You don't convert it, just leave it there. The next one is discharge coefficient for nozzle type, then discharge coefficient for orifice type. Now we have to type both there. I just want to make it simple with you because in real life I might not need the two. I will just type the choke here. But let's do it the simplest way. So what is this discharge coefficient? If it's a nozzle type, you have the equation here. We are going to use Reynolds number of 1 million. So that's the C. So I'm going to put that equation there for nozzle type equals this is the equation we are trying to equals beta, which is the diameter ratio. So I click on that, plus 0.3167 divided by slash beta to power of 0.6. So beta is diameter ratio. I click on that again. Then I do cap, shift 6, that's the cap. Then 0.6, cap 0.6. Then plus 0.05, plus 0.05. That's it. So if I have a nozzle type, that will be my C. If I have orifice type, then I have to type the equation there, equals. The equation for orifice type is this. Now you see you have a bracket multiplied by another bracket. So I have to start with a bracket, equals. Now you have to use the regular bracket. Don't use the square bracket. Excel doesn't recognize that. The regular bracket, that's the one as shift 9. That's the regular bracket. I open it. Then I have 0.59, 0.59887 plus 0.468468 multiplied by beta to power 4 star. Beta is, that's the diameter ratio, cap 4, again shift 6, that's the cap 4 plus 4.68 multiplied by beta raised to power 12. That's, I click on that. That's my beta, cap 12. I close the bracket, okay? Then I'm going to multiply, which is star. In fact, this other one, I don't need to put it in bracket because I'm taking the entire square root of everything. In Excel, square root, I can do it two ways. I can put it in bracket and put cap 0.5. 0.5 is square root. Then there's also a square root function in Excel, so I'm going to use that. SQRT. So I do star SQRT. So I'm going to open the bracket. SQRT of what? 1 minus beta raised to power 4. 1 minus beta. I click on beta again. Cap 4. Shift 6. 4. Then I close the bracket. So actually I will take the square root of that. And that's it. You see, so if I'm using orifice type, the discharge coefficient will be 0.74. If I'm using nozzle type, the discharge coefficient will be 1.7. Now, this next line, which is the choke discharge coefficient, which is what I'm actually going to use in my calculation, is going to select one of these. So how do you select one of them? To know the right one, I'm going to read this input there. I said for nozzle I put 1, for orifice I put 0. So I'm going to read cell C18, whatever value is there. So in Excel you use the if function to select the right one. So I'm going to do equals if if, then you open the bracket. The if function would, the first statement is, what do I want to test? So what I want to test is, I want to check what, I'll click on this value. If the value here in cell C18 equals 1, then the next thing I put a comma. So I just put, I click on this, I say equals 1. So I'm going to read the value there. If it's equals to 1, then you put comma. What do we do? I'll just click on what it's going to use. I'll click on cell C24. So it's going to pick cell C24 as the discharge coefficient. Otherwise, then you put another comma. Otherwise, comma. Otherwise, you use the next one, which is C. I click on C25. I close the bracket. So Excel will choose the right one. See, Excel choose 1.17 because it reads 1 there, which is nozzle. So it's going to select one of them. So that's the one I'm going to use in my calculation. So now the next one is the actual pressure ratio. The actual pressure equals, my pressure ratio is the downstream pressure, which is area here, cell C12 slash cell C11. Okay, I do okay. 0.8 in my case. Then the next line is the critical pressure ratio. You know, the pressure ratio is that. The critical pressure ratio is the pressure ratio at which the flow will become sonic. When it's going to have mark of 1, that's the moment you say the flow is choked. So, and that's going to be the max. It's going to be the point where you have the maximum flow rate. So, how do I get that? Critical pressure ratio equals, the equation for that is that's the equation there. The critical pressure ratio is RPC. So let's look at it. I say equals. If you look at the equation there, I put in bracket 2 divided by K plus 1. So I start with a bracket. 2 slash, I have to put K plus 1 in bracket. Otherwise, it's just going to do 2 divided by K, then plus 1. So I have to open another bracket. K plus 1. Where's K? K is the gas heat ratio, which is, I click on that, which is C16. Then plus 1. Plus 1. Then I close that bracket. So that's K plus 1. I close the bracket. Then I close the other bracket, the first one which I opened. So I have to close that. Now in Excel, you have to, all your open and close brackets must balance. The number of open brackets must balance. So I've completed 2 over K plus 1. Now I want to do raised to power this. So I'm going to do shift 6 again, which is cap. Now I have to put everything there in another bracket so that it doesn't. You can use as many brackets in Excel. It's even safer because so that you don't make mistake. So I have to put that expression K divided by K minus 1 in bracket. So I open the bracket. So I do K. I click on K slash. So I have to put K minus 1 in the bracket. So I open another bracket. I click on K again. Minus 1. I close that bracket. Then I close the first bracket too. So that's it. That's my critical pressure ratio. 0.5 0.5549. When the pressure ratio is 0.5549, the flow becomes sonic. Next line. Flow regime is sonic or this one. Now how do I test whether the flow is sonic or subsonic? So what I'm saying is, if it's sonic, I have to put 1 there. Unlike the input, I put it here, but here I want Excel to put 1 there. If it's sonic, then it will put what? 0 if it's subsonic. So this, we are going to use another if equals. If, how do I know? I'm going to check my actual pressure ratio, which is where? My pressure ratio is what? My pressure ratio is this, C27. So I click on C27. If this number is less or equals to, so I'm going to do is less or equals to the critical pressure ratio. I click on that. If my pressure ratio is less or equals to the critical pressure ratio, then I have to put 1, which means it's sonic. So I say comma, type 1. Otherwise, comma, another comma, type 0. Okay. You see, Excel is going to put 1 there. No, it's going to put 0 because it's subsonic. Okay, so it's 0 because it's subsonic. Now, this is the main, we are getting to the main job there, to calculate the flow rate for sonic flow rate and subsonic flow rate. That's what we're actually looking for. Now, the sonic flow rate, that's the equation there, is you also provided. Then the subsonic flow rate, that's the equation there. So for sonic flow rate, let's do the equation. It looks long, but you have to be very patient. Equals 879 multiplied by my C. My C now is what? Cell C26, because that's the one XX selected. Then multiplied by star the cross-sectional area, which is C23. I click on that. Then multiply by upstream pressure, which is C11. I have to go there. C11. Okay. Then multiply by square root. Okay, now let's use the function square root again. I don't need to put, when I'm using the function, I don't need to start with bracket. So I'm going to do star square root. SQRT. Then I open the bracket. So I'm going to put everything in bracket. If you don't want to forget to close the bracket, just you can close it and let's start with. So what am I doing? I'm square root of. I have to put this one in bracket, the first one. So I do open another bracket. K divided by. So I type on K. Okay, I have to go up. That's C16 divided by gamma specific gravity C15, then divided by again slash again upstream temperature. You have to use Rankine, so I'm using this C21. Then I close it. Remember, every time you have divide, you keep using slash slash. Now multiply now by star. I open another bracket. 2 divided by, for K plus 1, I have to use a bracket. So I open another bracket. If all your brackets you open, if they don't work, Excel would let you know. Now, what is the first thing? K plus 1. Okay, I click on K. K is 1.25 plus 1 plus 1. I close that bracket. I'm following this. So I just close K plus 1. So I have to close the other bracket now. I close the other bracket. Then that one, cap, which is raised to power, shift 6. Now I'm going to have a lot of brackets there. I open the bracket. So I want to do K plus 1 divided by K minus 1. So all of them I'm going to put in one bracket. So I'm going to do K plus 1. So I have to put K plus 1 in bracket. So I open another bracket. I click on K. C16 plus 1. I close that bracket. Slash divided by K minus 1. I open another bracket. I click on K. Minus 1. Minus 1. I close that bracket. Then all the power now I have to close, because I started with a bracket, so I close everything now. So that has completed everything inside the square root. You remember I started open the square root, so I have to close the bracket for the square root. That's it. So at the end I have 3 closed brackets. If you don't have enough brackets, or you don't close all your brackets, Excel will yell at you. So the next one is to calculate for subsonic. The equation for subsonic is this one there. Remember, if you see sonic, you only use the upstream pressure. For subsonic, you need both upstream and downstream pressure. You have the explanation in your note. Why doesn't the sonic equation has downstream pressure? It's because the downstream pressure doesn't affect, once the flow becomes sonic, whatever you do, if you keep lowering the downstream pressure, it doesn't change. The flow is already maximum. That's the maximum flow rate you can ever have. You see, if I calculate for subsonic now, it's going to be less than 64.78. So let's do that. Equals 1248. That's the equation there. 1248 multiplied by star C. My C is C26 multiplied by A. Area is C24. No, C23 multiplied by upstream pressure star upstream C11. I click on that. Then multiply by square root again. I start star. I write SQRT. I open the bracket. Sometimes if you've been working with Excel, I can close the bracket immediately so that I don't forget. Then I click back to put all the functions inside. But let's just do it this way. So now see everything I want to put in the bracket. So this one bracket multiplied by another bracket. So I open one bracket. I open one bracket. Just read this. Whatever I'm typing is here. I open the bracket. I do K. So K. Go up there. That's K. C16 slash. I have a lot of things there. Slash divided by K minus 1. So I have to put K minus 1 in bracket. So I open one bracket. Divided by K minus 1. K minus 1. Minus 1. I close the bracket. Slash again. Slash gamma specific gravity, that is C15, then divided again by temperature slash upstream temperature in Rankine, which is C21. So I close the bracket now, all the other bracket. That's this bracket. Now I do multiply by star. I open another bracket to put everything there in the bracket. So the first one there is the pressure ratio to power 2 over K. The pressure ratio, I don't need to put that in bracket. Where is the pressure ratio? The pressure ratio is C27. I click on that. Then cap. When you are putting cap, that's anything you want to put in the power, put it in bracket, because if I say 2/K, you can just do raised to power squared divided by K. So I'm just going to put 2 over K in bracket. It doesn't hurt if you have too many brackets. To be safe, just learn how to use bracket. So I do bracket 2/ I do K again. I put that one in bracket. So I've done the first part, which is R raised to power 2 over K, then minus. I have to put, okay, I click on R again, pressure ratio, which is C27, cap, raised to power. I open bracket for the power. K minus 1 over K. I have to put K minus 1 into bracket, so I put another bracket. I do K. K minus 1. I close that bracket. Slash. Divided by what? K. So I just click on K. I don't need to put that in bracket. I just click on K. But I have to close all the brackets now because I start with bracket. So I close that bracket. So I've done with this. So I have to close the bracket for this expression, R to power 2 over K. So let's close that bracket. Then the next bracket I have to close is the square root bracket. That's the end. So I close the square root bracket. All brackets are closed. This one also ends with 3 brackets, close bracket. Okay, it's giving me exit. What's the problem? You can't calculate it. What's it? I must have made it. Let me see. 1248 multiplied by C26, that's C. Multiplied by C23, that's A. Multiplied by C11, that's the upstream pressure. Then multiply by square root of, I open the bracket, K divided by, oh, that's the problem. Wait. Okay, K divided by K minus 1, then divided by gamma, C15, then divided by C21, then I close the bracket, multiply by C27, that's R. I have to start with the bracket. Okay, start with the bracket. C27 raised to power 2 over K.